All right, so what we're going to be doing here is just a little quick tutorial on how to do a one-dimensional momentum problem. So we'll talk about, say, we have two carts that are going to be coming in and colliding with each other. So we'll have one cart here. Okay, let's give this, say, 3 kilograms. And how fast you want it going? So we're going to have 3 meters per second. Let's keep it standard units. And for our second cart, do we want it moving or not moving? Standing still. And how much weight would you like on it? So this one's going to be 5 kilograms. So this could be a really easy problem if I have them stick together. But you know what we're going to do? We're going to make it a little trickier and have them not stick together after the collision. Okay? And so after the collision, what we're going to do is we're going to have this same 5 kilogram object here, and we'll have it going, I don't know, let's have it going, say, 2 meters per second. Okay? So this is our before area on top, and then we have our after area underneath. Okay? And the key to all of this is that the total momentum, P total, right, is going to be the same above as below. Okay, and so that's going to be the whole guiding for all of this. And so when we look at our P total before the collision, I think it's pretty straightforward that the momentum of this one is 0 kilogram meters per second, and then the momentum of this one is 9 kilogram meters per second, and then we want to be careful. We want to say the direction, right? So we'll go ahead and call that east. Okay, so we have 9 total kilogram meters per second before, and that means we're going to also have 9 after. So the key to remember here is that our P total before the collision is going to be exactly the same as our P total after the collision, and that enables us to right now go ahead and say this equals 9 kilogram meters per second east. Okay? But right now, it doesn't look like we have 9 kilogram meters per second east afterwards. We've got a 5 kilogram object going 2 meters per second. It's going east, so it looks like the momentum down here in our after is 10 kilogram meters per second east. And it can't be that because we have to have 9. Okay, so luckily we have another cart here. Right? We have this 3 kilogram cart that was the one that initially hit it. And if we're asking, okay, what is that thing doing? We've got to stop, consider what's happening. So again, at the start, 9 kilogram meters per second east. That means afterwards, we've still got to have 9 kilogram meters per second east. Okay? That's our combination total momentum. That's what it's got to be. Since I've got 10 kilogram meters per second east already on one of the objects, then I hope it's clear that the other object needs to be going west, and it needs to have a momentum that will exactly cancel the 10, so that instead of having 10, we have 9. Okay, so I hope it's obvious that at this point we can say that our momentum going this direction, west, has to be 1 kilogram meters per second. And that way, and that's west. And the point here is that our west of 1, along with our 10 that's east, right, gives us exactly what we needed, which was our 9 east that we had before the collision. Okay? So now the question was, what's the velocity? And so we just need one last little step. And so we can go ahead and just say, since momentum is mass times velocity, velocity is momentum divided by mass. Our momentum is 1, our mass is 3, right? And so we get a velocity of 0.33 meters per second west for the other cart. Okay? And that's a pretty straightforward one-dimensional problem. Just to make sure everybody's on the right page as far as conservation of momentum. We'll look at a harder two-dimensional problem in the next movie. Thanks. Hope it helped a little bit.